Bright Tuty. Every student matters.
Hello dear students, welcome to another lecture. In this class, we are going to begin with Class 12 Education Nagaland Board and the 14th unit of the same, which is the measures of central tendency. In the previous lecture, we discussed about how to calculate arithmetic mean in case of an individual as well as a discrete series using the three methods: the direct method, assumed mean method, and the step deviation method. In this class, we are going to discuss about how to calculate the arithmetic mean in the continuous series. Now, continuous series is that series in which there is a class interval which is given to you. 0 to 10, 10 to 20, 20 to 30, or 50 to 55, 55 to 60, and so on and so forth. So, whenever you are given with a class interval, that series is known as a continuous series, and you have to calculate mean in your continuous series as well. The most important thing that we need to learn before we proceed towards the calculation of mean is to know what the midpoints of the class intervals. Now, since we are talking about the continuous series, your series can either be, an exclusive. You see, the upper limit and the lower limit of the two are same. There might be a few series in which this is not the same. Okay, for example, 0 to 10, 11 to 20, 21 to 30, 31 to 40, and so on and so forth. There may even be some series in which the class intervals are not equal. 0 to 10, 10 to 15, 15 to 30, 30 to 50, and so on and so forth. Here there was a gap of 10. Here the upper limit and the lower limit are not same. And here there was a gap of 10, then 5, then 15, then 20. So these are the different kinds of continuous series that you might get. For you to, in your papers, you will have to expect the first type of series where there are equal class intervals and it is easy for you to calculate the midpoints. How to calculate the midpoints now? The first class interval was 0 to 10. How do I calculate the midpoint? The lower limit plus the upper limit divided by 2, which is 5. So the midpoint of the first class interval is 5. Second was 10 to 20. So the lower limit plus the upper limit divided by 2. So 30 divided by 2, which is 15. The third class interval, 20 to 30. So lower limit plus the upper limit divided by 2. So 50 divided by 2, it is 25. So this is how we calculate the midpoints in case of a continuous series. Now, let us first talk about, again, this has got the same types of methods. We have the assumed mean method, we have the assumed mean method, the direct method, as well as the step deviation method. Let us learn about each one of them. So this is the data which is given to you. I hope it is visible to you all. My X was the mark 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. The number of students who got those marks: 5 students who got between 0 to 10, 12 students who got between 10 to 20, 15 students who got between 20 to 30, 25 students who got between 30 to 40, and so on and so forth. The next thing, as I told you, that we have to compute is the middle value. Middle value, as we've learned, 0 plus 10 divided by 2 is 5. 10 plus 20 divided by 2 is 15. So 25, 35, 45, 55 and 65. So these three steps will have to be the same no matter whether you are calculating using the direct method, the assumed mean method or the step deviation method. Now if I talk about the direct method, what is the formula for calculating mean using the direct method in case of a continuous series? Sum of f and m. Now I am multiplying my frequency with the middle value upon sum of m. For example, marks, frequency, the middle value, 5, 15, 25 and 35. According to my formula, I need f into m. So f into m is what I need. So 5 into 2 is 10. Then 15 into 3 is 45. 25 into 1 is 25 and 35 into 4 is 140. Right? Now what do I need? I need the sum of all these f. So 140 plus 25 plus 45 and 10 gives me 220. And I need the sum of my f also. So 4 plus 1 is 5, then 6, 7, 8, 9 and 10. Now apply the formula. 220 divided by 10, which is 22. So my average mean is 22. So it is almost the same as the discrete series where you are multiplying your frequency with m. Here it is m, not x. M is also derived out of x over here. The second method is the assumed mean method. What is the assumed mean method? The formula is mean is equals to A plus the same formula, FD divided by the sum of F. This is the formula for calculating mean according to divided by the sum of frequency. Again, what is D? D is X minus A. From where are you going to take the A now? A is to be taken out of M, the middle value. Let us look at an example now. My marks were given to me 0 to 10, 10 to 20, 20 to 30, 30 to 40. The frequency 2, 1, 3, 4. What is my middle value? 5, 15, 25 and 45. Okay. Now, according to my formula, which is A plus sum of FD divided by sum of F, I need D. And what is D? D is X minus A. From where are we going to take the assumed mean now? From my middle values. Let me take 25 to be my assumed mean. So 5 minus 25 is minus 20. 15 minus 25 is minus 10. 0 and 10. I have D now. What do I need next? I need f into d. So let's multiply. 2 into minus 20 is minus 40. 1 into minus 10 is minus 10. 0 and 40. Right? What did I need now? Let me start putting the values. I needed a, which is 25. I need the sum of f and d. So 40, 40 cancel. I am left with minus 10. So minus 10 upon the sum of my frequencies. So 4, 5, 6, 7, 8, 9 and 10. Now let me calculate it further. This is 25 minus 10 upon 10. 1. So 25 minus 1 is 24, which is my average mass. So simple enough, just the way we've learnt in discrete series. The only difference is I assumed my mean out of the middle values now. And the last method that we have is the step deviation method. Right? Formula A plus sum of ft dash upon sum of f multiplied by the common factor. This was the formula that we learned in the discrete series also. D dash is equals to x minus a and c is equals to the difference in the class interval. Let us look at the question to understand it better. Again, we have the marks 0 to 10, 10 to 20, 20 to 30, 30 to 40. The frequency is, let's say, 2, 1, 3, 4. Next, I needed my middle values. 5, 15, 25 and 35. Then I needed D, which is x minus a. A was 25. So minus 20, minus 10, 0 and 10. Next, according to my formula, which is I need D dash. And what is my D dash? My D dash is x minus a divided by c. Common factor. Common factor, as I told you, is the class interval. What is the difference in the class interval? 10. So D divided by 10 is minus 2, minus 1, 0 and 1. Next step is to calculate f into D dash. So 2 into minus 2 is minus 4. 1 into minus 1 is minus 1. 3 into 0 is 0 and 4 into 1 is 4. Right? Now let us apply the formula. A 25 plus sum of fd dash. So minus 1 divided by the sum of frequency, which is 10, into the common interval, which is 10 again. This is nothing but 25 minus 10 into 1 is 10 upon 10. 25 minus 1, which is 20. So the formula for the direct method, the step deviation, as well as the assumed mean method in the continuous series also remains the same. The only difference is that discrete series, we took the assumed mean from the observation, that is x that was given, while in the continuous series, we took it out of the middle values that were given to us. Okay. Now, in your book also the same thing has been done. The example is the same. The methodology is obviously the same. And they have applied and calculated the assumed mean. So the step deviation method, as I have told you, how to obtain that. Now, the sum of deviations of the item from the mean is always equal to 0. That means the sum of deviations, the D that you calculated, so the sum of deviations of the items from the arithmetic mean that you have calculated is always going to be 0. And arithmetic mean is always affected by its values. If the large value, if there is another large value which is added to it, the mean is going to change automatically.